Hi students, in this video we're going to look at how to solve simultaneous equations. Part 2 of this series, looking at how we solve them using substitution. So the learning goal of this video is that by the end of watching this video you should be able to solve simultaneous equations using substitution. Things to remember, students, most of the time when we're using substitution, one of our equations might be in gradient intercept form with y on its own, or any equation where you've got x on its own. So x equals 2y minus 7. Ideally, when using substitution, one of our equations should have x or y on its own. We'll also have to remember how to substitute values into an equation. Both of those skills and both of those ideas we'll use in this lesson. Now, solving simultaneous equations using substitution involves, as the name suggests, substituting one equation into another. This is done best when the variable is the subject of an equation, just like it is in those examples on the previous slide where you've got y equals something or x equals something. That's the best way and the best time to use substitution, when you don't have to do much rearranging to get one of those variables on their own. The steps for solving simultaneous equations is numbering both equations and any new ones that are created. So for example, the first equation will be labeled number 1, the next one will be number 2, etc. You don't need the circles around them, just numbering your equations as you go through helps with your communication and helps with your reasoning. Make sure one variable is the subject of an equation. You might need to do a little bit of rearranging to make one variable the subject or on its own in an equation, but if it's not, or if it needs to be done simply, that's the second step there. Once you've done that, you're substituting that equation into another, and that's where this whole name of substitution comes from. We'll see what that looks like in a moment. Once you've substituted that value in one equation into the other, you can rearrange and solve for one variable, and once you know one variable, you can substitute it into one of the equations you started with to get the second variable and rearrange for that. Finally, it's worth checking your solution to make sure that the solution you've got actually makes both equations true at the same time. Alright, so let's do an example. We've got y equals 4x minus 1 and 3y minus 7x equals 4. Now, we've got y on its own up here. So this set of equations is a prime one to use for substitution. As soon as we see x or y on its own, we should start thinking substitution. So numbering our equations, we'll call that number 1, we'll call that number 2. And in our communication, we just want to write short, sharp sentences explaining what we're doing with each step. So this first step is we are going to substitute equation 1 into equation 2. So we've got y equals here. So in this second equation, wherever we see a y, we are going to substitute it for this part of the equation. Because we're told, this first equation tells us that y is the same as, it's equal to, it's equivalent to, it's exactly the same as 4x minus 1. So instead of writing y, I can write 4x minus 1 because our first equation says they're the same thing. And then keep writing, minus 7x equals 4. And then going from there, we can expand and then solve this equation. So 12x minus 3 minus 7x equals 4. 5x minus 3 equals 4. Continuing to rearrange. 5x equals 7. X equals 7/5 or 1.4. All right. Now we've got our answer of 1.4, we can substitute that. I'm just going to use a fraction, 7/5, into equation 1. I could have substituted it into equation 2. Equation 1's fine, especially since y is already on its own. So y equals 4 times 7/5 minus 1. I'm going to combine this into one fraction, so 4 times 7 is 28 on 5, minus, same denominator, 5 on 5 equals 28 minus 5 is 23 all over 5. We change that to 5 over 5, so we could combine these numbers together. Just multiply top and bottom by 5. Same denominator, put them together. And so there's our solution. We should have if you want to write it out, that would be 4.6 as a decimal. Now, we've got our solution. We should probably check it. That's good for our communication to do a check. So we're going to check using equation 2. So we used equation 1 to work out y. So we know x and y should work for that equation. We don't know if it's going to work for that second one. It should, but that's why we need to double check. And we can't use 1 again because we just used that in that previous step. So we'll use the other equation in our check. So subbing those values in, we've got 3 times 7/5. Oh, sorry, that's not right. We've got 3 times our y value, which is 23 on 5, minus 7 times 7 on 5. And we're just going to look at the left-hand side of this equation to start off with. 3 times 23, that's going to be 69 over 5, minus 49 over 5. Same denominator, so we can subtract those values. 69 minus 49 is 20. 20 over 5 is 4, which is the same as the right-hand side of our equation that we started with. So therefore, we know the solution is the x value is 7/5 or 1.4, and the y value is 23/5 or 4.6. We could also write that solution as a set of coordinates, or 7/5, 23 on 5. You don't need to write both solutions there, students. One or the other is fine. Alright, so after watching that video, you should be able to solve simultaneous equations using substitution.